Combined inequalities. So the idea here is we have two inequalities, and specifically we have what's called an interval with endpoints A and B. And just we're going to do the included endpoints. It's true even if they're not included. We have A being less than B. We're looking basically at this piece of the number line. And it starts at A and ends at B. So the way that would be put in inequality form is that X has to be greater than A, right? But it then also has to be less than B. If I say the X greater than A and the X less than B, I end up with these two arrows and they overlap there in the middle. But what I actually want is that overlap, right? So to make it clear that only the overlap is wanted and we don't want those other parts of those inequalities, we're going to combine them into one inequality. And the thought process behind this is we can rewrite the X greater than or equal to A as A is less than or equal to X. Those are equivalent. And so now we have A is less than or equal to X and X is less than or equal to B. And we're just going to kind of merge that middle part into just X. So we get A is less than or equal to X is less than or equal to B. So in set builder notation, rather than having the set of all X such that X is greater than A, X is less than or equal to B, we're going to use that combined inequalities, the set of all X such that A is less than or equal to X is less than or equal to B. And again, this works if it's just less than and greater than as well. Now, just because we have two inequalities doesn't mean they can be combined in this way. If A is less than B, so again, we have that number line with A and then B somewhere to the right of it, then if we have the set of all X such that X is less than or equal to A, so now we have this piece, and X is greater than or equal to B, now we have these two separate pieces. Those can't be combined. So we have these opposite rays that don't overlap. So those have to stay as those two separate inequalities, that the set of all X such that X is less than or equal to A, and X is greater than or equal to B. That is a valid type of inequality you will see. Now, on the other hand, if you come up with a solution that has two same direction inequalities, you've made a mistake. You shouldn't have that. So those would be graphed basically two rays pointing the same direction overlapping. I would tell you what to do with them, but you don't need to. All you need to know is if you're seeing that, that's wrong. You've made a mistake. One of your inequalities is pointing the wrong direction, but you have to pay attention. You can't just say, well, I'm going to flip one, because depending which one you flip, you either end up with that combined single interval or those two separate pieces. So there will be processes you'll be taught to tell you exactly how to know which direction the inequalities should be and which ones should be switched. So a couple of the comments about the combined form, we want to think left to right. So if you have the interval between 2 and 3, you want to write that as 2 is less than X is less than 3, not 3 is greater than X is greater than 2. You might, in the process of doing calculations, get something that looks like this. So you need to know how to just flip the whole thing and turn it into that standard form combined inequality. And then we have some forms that are just flat out don't work, shouldn't be a combined inequality at all. So 2 is less than X is less than 1. If I split that, we have 2 is less than X is less than 1. Notice 2 is not in fact less than 1. So already this kind of breaks. But really we have then those two separate rays. X is greater than 2 and X is less than 1 that would need to be kept separate. If I have 2 is less than X is greater than or equal to 3. So now we have the separate inequalities. 2 is less than X and X greater than or equal to 3, but that would be X is greater than 2 and X is greater than or equal to 3. So this would be a nonsense form. We would have those two rays going from 2 and from 3 in the same direction. And then similarly with 2 is greater than or equal to X is less than or equal to 3. So the invalid forms combined will have the inequalities pointing in opposite directions. Separate would have the two separate inequalities that are the same direction inequality. So the correct combined inequality has always the less than or equal to. So the pointing in the same direction, but they're a combination of two inequalities that were opposite direction. So hopefully that's not overly confusing. You can figure out if you can graph the separate parts and kind of see, you'll get the hang of what is correct and what isn't. All right, so some practice. We're going to look at these pairs of inequalities, figure out whether they can be expressed as a combined inequality. If so, combine them. If not, figure out, is this at least even a valid solution set, or is something wrong? Right, so x is greater than or equal to -5, x is less than or equal to 2. If you're not sure, just looking at it, draw a graph. So we have, I'm just going to mark -5. So then somewhere there's going to be 0, and then 2 on the other side of 0. I'm not too worried about the scaling, but just having them in the right order, right? So I have the -5 first, and then the 2. I want greater than or equal to -5. So going this direction to the right, and then less than or equal to 2. So from the 2 going to the left, and we have those two overlapping rays. That's exactly the type that can be combined. So we would write that then as -5 is less than or equal to x is less than or equal to 2. So just looking at the inequalities, if you switch the direction of that first one to be -5 less than or equal to x, the important thing to note is then the -5 is in fact less than 2, then it works. Next example, x is greater than 1 or x is less than 2. If I rewrite the x greater than 1 as 1 less than x, and then put the 2, the less than 2 on the other side, well, 1 is less than 2, so that one is good. Again, you can graph that. We have the 1 and the 2, the x greater than 1 pointing to the right, x less than 2 pointing to the left, and they have that overlap in the middle. That's what we want. Now, x is greater than or equal to -2, x is less than -5. If I switch and have the -2 less than or equal to x and try to put that together, we have a problem because -2 is not less than -5. On the number line, we have 0, and then -1, -2, -3, counting to the left, -5. So -5 is left of -2. So we would need to have greater than -2 pointing to the right, less than -5. Sorry, that was greater than or equal to -2 with a square bracket, less than -5 pointing to the left, and there's no overlap. So these would have to stay separate. But this is a valid solution set, but not combined. Then we have x is greater than or equal to -4, x is greater than or equal to 3. That's not valid. We have two of the same direction. If we rewrote, we would end up, we couldn't just switch one of them and have the right form for the combined inequality. There is no way to write them correctly that would have the x in the middle. And likewise, the x less than 0 and x less than 6 is invalid. So that's combined inequalities.